Okay, let's go ahead and talk about how we use matrices in a useful way. So, mathematically, of course, there's lots of things we can do with these. And you remember those pesky little determinants? Well, they just kept popping up, and here's one of the places they can pop up. We're trying to do the area of a triangle. And what happens is, though, they give us three coordinates of the vertices, okay? So I don't know the lengths of the sides unless I go and calculate them and all that kind of thing. But let's say they gave us just the position of the vertices. So that's the kind of thing you get with latitude and longitude, you know, and those sort of things too. So let's do this. 2, 2 is the second vertex, and 4, 3. Alright, so what happens is you're going to take this formula for the area and construct a determinant, okay? The area is equal to, it says plus or minus, and what this means is the answer might come out positive, it might come out negative, but you're going to fix it because of course you want the area to be a positive quantity. So whatever it takes to make it positive, that's what you're going to do. Here's that 1/2, and that kind of is familiar from triangles. But now what we're going to do is we're going to construct a determinant using all the vertices as a row, but remember it has to be square in order to take a determinant. And so we're going to put 1s in the third column. So it looks like this. 1, 0, and there's the 1 in the third column for the first point. Then we'll take this second point, 2, 2, throw the 1 in the third column, and 4, 3, and a 1 in the third column. So this 1 in the third column is always there, like that. So what we need to do is calculate this determinant, and then we'll be able to get the area from that. So, let's see if I can do this fairly quickly. The area, plus or minus, I'll have to see if I need the plus or the minus. I'm going to use the expand on the first row because it has a 0 in it. So, let's see, I take that first entry in the 1, 1 times the sign pattern times the determinant of what's left when I cancel that and cancel that. I get 2 minus 3. That'll be a minus 1 when I get there. I don't need to worry about the 0, but I do need to worry about this one as well. Okay, so I'm going to add 1 for the entry. The sign pattern is still a 1 because I alternated. The 0 would have had the negative. And then I need to do the determinant. Let me switch my color for you. When I cancel that first row and then the third column. So the determinant of 2, 2, 4, 3. So do that diagonal and get 2 times 3 is 6. Okay. Minus 2 times 4 is 8. Okay. So plus or minus, let's figure out what we'll need. 1 times a negative 1 is minus 1. Plus 1 times a negative 2. So what I'm getting is plus or minus 1/2 times a negative 3. So that's going to be 3/2. And always make the answer positive. No matter what it had come out for the determinant, the answer for the area has to be positive. Okay, so that's one way to use a determinant to do a nice calculation. Good. Okay, we can get a little more fun, still a little nerdy, talking about cryptology, and you can use matrices here to code messages, right? So cryptology is all about coding messages, and of course you have to be able to uncode them as well. And my favorite cryptologist was Julius Caesar, and he was actually very clever with this. But here we're going to use a matrix method. Okay, so you start with the idea that every letter is paired with a number. So just write your alphabet out, A through Z, and number all the letters 1 through 26. That's the simplest kind of code you could come up with. So let's say we want to say, let's see, math is fun. And just to make things a little shorter, I'm not going to do spaces. So you'll have to parse it, like, figure out where the words start and end. But the M, of course, let's just do this, is a 13. The A is a 1. The T is a 20. The H is an 8. The I is a 9. The S is a 19. the F is a 6, the U is a 21, and the N is a 14. Okay, simplest code. Almost anybody could break that code. So what you do is you jumble up all the letters using a matrix. So this will be our coding matrix. Call it A, and let's give it some values. Okay, so there's my coding matrix. I chose a 3 by 3 because we're pretty good at that size. Of course, if I had a big computer or something, I could go much larger. And I need to parse my numbers here into a manageable size, a corresponding size to go with this matrix. So this, of course, was a 3 by 3 matrix. So I'm going to parse this into groups of 3. So what I do is I come up here and parse this. The first 3 letters are the first 3 numbers, second 3 numbers, and finally the last 3 numbers. So those are going to be matrices, and they'll be 1 row, 3 columns. So they're a 1 by 3 matrix, okay? So the first time we do this, let me change, that's a horrible color, B, 1 is equal to a matrix, 13, 1, and 20, okay? Then you see where B2 is going to be and B3. So what I'm going to do now is I have this coding matrix, which is 3 by 3, and I have a B matrix that has the numbers that I need to scramble up. And I'm going to come up with a coded matrix, okay? To make a code, I'll just multiply these together. And of course this was a 1 by 3, so I have to put the B first. So my coded matrix is equal to B times A. Okay? And then that will be this scrambled up thing that nobody else will be able to uncode unless I give them the coding matrix, which is the key to it all. Okay? So only you and your friend have this. You get together at some point in time, you decide what your coding matrix is, and then you can separate and communicate with each other because you are the only ones who know your coding matrix. Okay, so I'm going to go ahead and get my calculator out. And I'll put the matrix A in my calculator, and I'll put the matrix B in my calculator. Make sure you tell B when you're editing, second matrix, edit. A should be the 3 by 3, put in your values. Second matrix, edit. B, make sure you tell B is a 1 by 3. There's 1 row and 3 columns. And then put those in. Okay, so I put the matrix A in, I put the matrix B in, and I just got done saying that the coded matrix will be B times A. So I'm going to do that on my calculator. I used B1, okay? And let's see what I get. So I'm going to say second matrix, name B, and then I'll just go back and say second matrix, name A, hit the enter button. I have B times A, and I'm getting 32, negative 45, negative 51. And then I'm going to do that again with the second numbers, okay? Okay, so my second B matrix was that 8, 9, and 19. I don't have to go back in and re-enter A, it's already there, leave it alone. I'll just go back, second matrix, edit B, put the 8, 9, 19. So now I'm going to watch this trick. I'm going to do a second quit, and then I'm going to do a second entry. And you'll see B times A should be right there for you, and that's going to save you a lot of time because this can be tedious, I admit it. So second entry, enter that, and I'm getting the second matrix, 18, negative 26, negative 33. Okay, then I'm going to do the same thing for C3, which that was the matrix 6, 21, 14. When I do second entry after that again, I'm getting the new matrix minus 1, minus 5, and 19. So what you would do is now you've coded everything, and I would just send a string of numbers to my partner, just put them down together, and other people don't even know how many you've parsed together. So It's kind of another way to scramble things up. Okay, so this would be what you send to your friend, and he would be able to uncode it. So, how do you uncode? Well, that's easy. You know, we set this up that C was equal to B times A, okay, the coded matrix. And what I could do is multiply both sides on the right-hand side by A inverse, right? Then C times A inverse would equal B, the original numbers, okay? So that's what we're going to do. We're going to take the code times A inverse. Because remember, inverse is just undo whatever the original did. So that we're going to undo it. And you just have to get your order correct, okay? And of course you've got the inverse button on your calculator and it all works out great. So we're going to have you do this in class, making your own matrices. And those are both kind of nerdy things you can do. There's a lot of things out there. There's just so many things that matrices can do. One of my favorites is domination matrices for calculating the winner of a round-robin tournament. Team Raven beat Team Sparrow, but Team Sparrow beat Team Clover, and you work it all out, who beat who and all that, and you put it in a matrix and do some matrix math to figure out who would be the tournament winner. So it's kind of really interesting. I hope we have a chance to get into some of those too.